right now. So we've got a pulley system, and we've got 150 grams on this side. We have a 200 gram mass here, and we have a 100 gram mass over here. And the system we can move it, okay? But when I let go of it, what does it do?
Goes back to that.
It goes back to equilibrium, because this is when it's most stable arrangement. So when you have a situation like this, let's start with this. This is a 200 gram mass. 200 gram mass weighs 1.96 newtons. So the vertical component acting down is 1.96 newtons. So what does that mean in terms of the vertical components here? What do those have to add up to?
Zero.
The whole thing adds up to equal to 0. But this is, if this is negative 1.96,
Positive.
these two together have to add up to
Oh, 1.96.
1.96. Okay, so the negative 1.96 plus these two values have to add up to 0.
Oh my gosh, dude.
The whole thing is going to add up to equal to 0. But these two values here have to add up to 1.96. So if you know one of them has a value of 1, the other one has to be
0.96.
0.96, because these two values add up together, right? So when you look at this tension, so pretend that none of this exists. When this is being held up, and this is like 150 grams, gravity is pulling down with a certain amount of force. That means the tension in this string is balancing out that weight. So if you know the tension at any point in this string, you know the tension at every point in the string, as long as it's static, and it is. So instead of putting a Newton scale here and getting a reading, what we're doing is we're letting gravity generate that amount of force. So I can either pull this up with my hand and measure it, or I can set up a pulley and let this downward force here create the hypotenuse. So in a situation like this, whatever the weight is hanging down is what's the value for the hypotenuse is. So over here, this math is simple. Here's a 100 gram mass. That's 0.1, that's 0.98. So that means the tension here is 0.98. That means the tension here is 0.98. So it's the same idea. If I know this is 0.98, and if I can measure that angle, I can find the horizontal and vertical components of that force. If I know this is 1.5, which is about 0.15, about 1.5 total, okay? So if this is 1.5, this is 1.5, and again, if I know this angle and I know this angle, I can find those. So what should happen is that my x components are the same, but in opposite directions, and these two vertical components should add up to equal whatever the weight is down here. Okay? Got it? Good? Great. Okay, let's go back, and then I'll turn you, so I'm going to go to 1/3.